Hey guys, my name is Krzysztof Zabłocki and I work at Mashable, but you might have heard about me from either my open source work or Foldify. And today I will try to convince you to stop recompiling as much as you can. And we'll talk why, and maybe I'll even show a demo depending how fast I'll talk. So how does a normal day in a programmer life look like? So ideally we would like to think about a problem we have, figure out the solution, code it, and then see the result that actually works. But this is not really what happens. What usually happens is you get a feature request or you have a problem that you have to solve. You think about the solution, you write the code, then you compile the project, you put it on the device or the simulator, you run it, and then you wonder why the hell it doesn't do what you think it would do. And then you have to debug it, and you have to see what was wrong with it. Then you have to change the code, run it again, compile, watch the spinner to load, and check again why it doesn't work. And that goes around quite a few times before we actually make something that we are happy with. And this is like just problem solving. But when you come to more refined programming, like when you're working on UI or user experience, it gets even more complicated because there is a lot of tweaking involved. And the problem with this is it's not the thinking, it's not the coding, because this is something we cannot avoid. We have to actually try different things and experiment with the code we write. But it's the process of compiling and then deploying to the device or the simulator that takes a lot of time, and it kind of breaks our connection between what we think we would like to see. So we write in our languages, usually Objective-C. We write the expressions, and then we have to wait to see if they actually do what we thought they will. So this is why I would like us to stop recompiling. And the reason for stopping the recompiling is because this is #1 excuse for slacking off. And you probably saw this comic on XKCD, but it's a common thing that happens. Every programmer knows that compiling takes a lot of time. So you have time to go to Facebook or Twitter and just sit there and wait for the spinner to finish and to see if your code actually worked. But the thing about projects is the bigger they are, the longer it takes. So for example, my Foldify has over 1,000 graphics assets. It doesn't have that much code. Like the code of the app itself is 15,000 lines of code, plus the external libraries, which will have, well, probably a few times that much. And it takes me 18 seconds to compile the project. And then if you count the deploy time, it's about 25 seconds total between each code change. So if I'm working on an algorithm, if I'm trying to figure out new way to do things, that's acceptable because I will spend a vast amount of time coming up with the solution and writing it. It's a lot of code to write. And then I can wait even half a minute. That's not a big pain for you. But if you are tweaking something that's visual or that's something that's interactive, there is a lot of delay, like 25 seconds. If you are trying to tweak a value for like the animation speed or the smoothness of the movement, that's a lot of time. It adds up a lot and very quickly. So let's say you're trying to iterate on a small part of the app. So in Foldify, you have the 3D preview. So if you wanted to tweak something there, for example, if you wanted to tweak the color, well, you could just change the code, right? And you'd like to see the result instead of having to actually reload the whole project, open the specific screen you were on. You just start writing code. And for example, let's say I don't want to see a box. I actually want to have a composed model of an object. So I'll just add an array. I'll reference the variable, and I just create multiple objects. And there is no delay between the code I write and the result I get. So I remove the whole expression. And this is the ideal situation. So I can experiment with different variables. I can very well learn the API I'm using as well, because I get immediate feedback. So I can try different param options. For example, I clearly didn't know how radians work when I tried to divide that. And as you can see, the results are immediate. So I wouldn't want to do code reload every time I'm changing something in the code, because then I wouldn't be able to show you that in under a minute. It would take me like 10 minutes or something. And if you do some calculations, and I did it for you, if your time per iteration is 25 seconds, like it is in Foldify, on regular day, I do at least 300 iterations, and that's not even like I usually go way higher. But even at 300 iterations, it's 2 hours wasted on compile and deploy. That's a lot of time, right? That's 1/4 of our work days. And if you do even more, like when I work at Mashable, I sometimes get to 500 iterations a day when I'm working on the UX. That's 3 hours wasted, over 3 hours that you could be doing something else. And it doesn't necessarily mean doing more work, but if you didn't have to work 8 hours, you just had to deliver something. So if you're working for your own company, or the rules in your company are you actually do your stuff, you can go home, you could be home 3 hours earlier and spend time with your family or do stuff you like. But time is not the only thing that matters. In my opinion, the problem with waiting for the compiler to do its job and deploy the application is that it breaks the connection between what you thought you want to achieve, writing the code, and then seeing the result. You get this gap. So it's not about slacking. It's more about, well, if I'm writing this code, I'm thinking about this now. I'm really focused. And then I have to watch the spinner. And then I can see the result. And then I can iterate again. So it's this constant break of your focus that kills the creative experimentation. If you, as you saw in the demo, if I just write code and I see the results immediately, I'm kind of tempted to change it and change some variables, adjust a thing here or there, and just see the results. And sometimes this leads to like such an amazing process. It just makes everything easier, and it makes your job more enjoyable, because it's just like it's fun to see. That's why we do what we do. We love creating stuff, right? So it's fun to see what you just wrote actually work. That's why I think it's very important that we shorten the loop, and Apple knows that. I mean, with Xcode 6, they introduced Swift playgrounds, right? Who wasn't excited when they saw the demo of the playground, like having all the animations and everything happen the moment you write? And playgrounds are a really great idea. Who of you actually saw the Innovating on Principle by Brett Victor? So this is a talk that inspired Swift playgrounds and, well, other people like myself. Basically, Brett talks about removing that compile time and just getting the results, creating different tools. So in his talk, he shows demos when he can actually click on a application and see which code drew that part of the application. So it's like this great iterative process that you can either use the code or either use the actual result to connect the two. So it's like this very close connection. And he showed some nice tweaks, like you could drag a variable and change how the character in Mario game would jump, so how high it would jump and stuff like that. And this is what Swift playgrounds were inspired. And Swift playgrounds do a few things very well. For example, the instrumentation. If you wrote Swift code, you can see on each line in the playground, you can see how many times it was executed, what were the results. And this is really useful when you are working on algorithms. So if you are trying to implement quicksort or any other things like that, it's nice to see every step on the way what was the result. And with Swift playgrounds, you get that. And it works really well, except there are a few things that are not really cool about playgrounds. In my opinion, they are not really useful for most of us. They are cool for playing with algorithms, but with our daily jobs, we don't usually play with that much algorithms, especially not the algorithms that just do some calculations. Most of the time, we are working on apps that end up in user hands. So what we want to focus is creating new UIs, new user experiences, new interactions. And Swift playgrounds don't really work with that very well. So first of all, there are different environments than iOS, even iOS simulator. So, for example, if you wanted to do interaction, it's impossible. You cannot have user interaction with Swift playgrounds. They are just passive display. Then you cannot use stuff like perspective transforms in Swift playgrounds. You can if you enable. There's this in the property of a playground. You can enable run on iPad simulator. Don't try that at home because it looks like you're gonna gets some this is like very weird. It just displays the simulator and just starts blinking and just doesn't work very well. And most of us still cannot use Swift. I still have to use Objective-C. And they are slow. Because the instrumentation is so powerful, they actually have to instrument every line of code. So every line of code comes with a cost. So to be able to see all the results, everything has to be compiled with a special way. So it takes quite a lot of time. It's not that immediate. And it only works in Xcode. So if you want to write code in app code, actually write production code, be able to refactor and all, that won't work. And probably most of you saw this, source kit service terminated. This is a common message we get with Xcode 6. So the question is, do we need to wait for Apple to fix those issues? I mean, I heard about radars that are still open like 3 years later after they were reported. So I wouldn't have very high hopes of getting all of those things that I don't like about playgrounds fixed anytime soon. And what about Objective-C? I mean, for most of us, I think it's still valid that Objective-C is the main language we use. In Mashable, we still don't use Swift, at least yet. I mean, at some point we might use it. I think it's a nice language, but it's still not that stable. And I have to focus on actually delivering products, not just playing with a new language. So I want something that works with Objective-C. So are there any alternatives that I can use? And if you know how Objective-C works, it's a very dynamic language, right? So it's built on top of C, and you get all the reflection or the power that gives us swizzling, so you can change how the method implementation works while you are running the application. So is there a way that we could actually use Objective-C dynamic nature to get some of the features that Swift Playgrounds give us? And the answer for that is code injection. And what code injection is basically a way for you to change only parts of your application and then change the implementation details. So let's say you are working on a project and you are working on a single class. Instead of reloading the whole project, most of the time it's unnecessary to change to recompile all the other classes, unless you have something like subclassing of the class you're working on. So instead, what you can do is you can just compile the class that you are working on, then load the bundle with the code and swizzle the methods. That way you get the new implementation with the existing data you already had, an existing state of the application. And there are two tools in iOS that allow you to do that. One of them is called Dicey, which is dynamic code injection. And Dicey works as a Clang proxy. So basically what you do is you install a fake Clang on your Mac. You only do it once. Once you do it, like the reason why you have to do it is because they have to record the params you compiled a file with, because we can specify that we don't want arg or we want this kind of optimization or this kind of warnings. So to be able to give us the exact same compile result that we get with normal build, we need to have all the params that are passed to Xcode build. Once you install the Dicey Clang proxy, you also have to add a pod to your project. And that pod gives you some nice features, like you are able to get notified when a class changes. So you can react to recompiling the class. And Dicey doesn't work on devices. You can only run it on simulator, and this is also for a reason. And most of the time you don't need code injection on an actual device, unless you are working on sensor data. But this is doable even. You can have a simulator and then just have a device that just transfers the data to your simulator. It's doable. And the other tool is Xcode injection plugin, and it works a bit different. It still does the same process, so it compiles the bundle and it swizzles the methods, but this actually works on device as well. So it's a plugin you can install, and it's like it doesn't have the normal proxy approach. It just works in your project. It used to require you to have the project paths, change the code, but right now I think it removed that. My favorite is Dicey, because it allows us to, I actually can script it from the command line, which is very useful, which I'll talk about later. But the question is, can we push it further? I mean, code injection itself is cool. I can change the implementation. But the problem when you're iterating on something is having the consistent state. So when I'm working on a class and I'm changing the implementation, I want to make sure that the code I execute right now, after like 20 iteration, is going to behave the same way it would behave when I just compile the project. Because otherwise, it's a waste of time. If it works now, but it doesn't work normally, that's not really helpful for me. So what I really want to see is Brett Victor vision that you can actually have this tight coupling between code and the effect of your code. So seeing all the results and playing with a bunch of other stuff. And this is one of the reasons that inspired me to create Objective-C playgrounds. And the reason, actually the main reason why I built it is I wanted to write a new blog post for my mirroring.info blog. And the blog post was supposed to be about 3D animations that you can achieve with just core animation and layers. So I opened a new Swift playground, and I started creating UI views, and then I started to work on perspective. So I wanted to create this perspective that you get. You probably saw the paper application that you can have this book-like design. So I wanted to recreate that with Swift playgrounds. I did it before with Objective-C. It took me like 300 lines of code. So I thought it would be a great article for explaining how to use Swift playgrounds to do some quick prototyping. But the problem was nothing happened. Like, I didn't get any 3D, I just had a flat view. And I was wondering what's wrong. And after some investigation and Stack Overflowing, I found that, well, you have to enable this run in iPad simulator, which is like an inspector on the playground itself. Also, I enabled that. And then what I saw was Xcode would run my code on the simulator, but it was kind of weird because the simulator started blinking. So my view for test was red color. So my whole simulator just started blinking like crazy. And I thought I'm going to have epilepsy or something not cool. So I thought to myself, well, if being able to test something that I want to create in a normal app requires me to run the simulator and kills the whole, it got even slower, as you can imagine. It has to run the simulator. Why wouldn't I just run everything in the simulator? Like make the whole playground a simulator. That way I can leverage all of the power of the platform that we already have instead of trying to build something again from scratch. I mean, why did they build the simulator if they are not going to use it later? So it took me about 3 hours to create a first prototype for Objective-C playgrounds. And I built it on top of the Dicey code injection. So this, like, the biggest kudos goes to them. And it's quite simple. What I wanted to have is all of the points I mentioned about Swift playgrounds that are not cool. So lack of interactivity, lack of parameterization, and slowness. I didn't want that. So instead what you have is you just run your simulator, you put it on top of the screen, and you have a worksheet view, which is the view you can add other views to, like a normal application, which you can interact fully. You can have buttons, you can have gesture recognizers, and everything else. And then you also have this timeline view, when you can log messages, you can log objects, but you can also add interactors, which I will show you in a second. And they are way faster than Swift playgrounds, at least 10 times faster. There is no, like as you saw in that wasn't a GIF, that was a video. Immediate result. You just have, like, I have 1 frame drop or something. And this is because I don't do real instrumentation. But for most of the time, I don't really need real instrumentation. And if I want to, I have a bunch of DSLs that I can use to actually make it very simple to instrument the code. But what's lacking from Swift playgrounds, and I thought it was a big disappointment not having that when Apple released it, is ability to tweak. So it's nice to be able to change the code and see the results, but many times I don't want to change just the number. Like, why would I change the number and then recompile the whole project? That's kind of wasteful. And changing a number requires actually writing instead of just dragging, right? If you can drag a value and see the result, that's so much better. So instead of changing the values here, how about I just introduce adjustable value for one of the params? So for the Y position, X position, Z position of the camera, and I just connect it in the code. And then I get the sliders there. So I can change the values, and I can see the results without recompiling the project. And then I can change them again. I can change the range. So as you can see, I set the Z position to small, so I just extend it. And then I can go further. I can do values that are automatically animated. So instead of me dragging the value to do something, I can just make it automatically animate and auto-reverse as well. And this is very simple DSL that you can use, and it's like very obvious. It's supports multiple types. It uses some of the more advanced Objective-C features. But for you as a developer, it doesn't really matter. You can write the whole implementation just with a couple of simple functions. And then you can see there are multiple results, and I can change the animation to be auto-reverse by just appending AR at the end, and it works really well. And if you look at the, you probably cannot see it that well, but in the top left corner, there's KZ Playground tick and a number, and it's 27 now. That's 27 iterations without reloading the project. And I get to 300. Add the time for the deployment, and you get crazy amount of time that's saved. And then the question is, do you prefer Xcode or do you prefer AppCode? Or maybe some people like to write code in Vim. I mean, I wouldn't write code in Vim, except for this demo. So here I'm changing the Objective-C code in Vim. And when I save the file, it just reloads. It doesn't matter if I use Vim. It doesn't matter if I use Xcode. Doesn't matter if I use AppCode. And the best thing is I don't need to change anything. So I can edit file in any of the editors or all of the editors at the same time. So instead of having to deal with the differences, that like preferences of people, I can just run the application and just start changing it from an editor. In a second, I dragged Sublime and I just changed some code in Sublime. Works the same way. If I opened Xcode and I would change the code, it would work the same way. So it's ID agnostic and doesn't really matter which version I use. I actually don't want to wait. Oh, okay. I'll just show you that I don't lie. So I'm just opening Sublime. As you can see before, I used Vim without color syntax or anything, which clearly suggests I don't use Vim daily. But then I open the same file and I just change some code and it will work the same way. And it's because it runs a daemon. So it's basically running a daemon in the console that observes all the file changes and then just reloads the code when it changes. So if I go here and I change some value, it doesn't matter what ID you prefer. And like I said before, it has the full iOS simulator. So you get all of the features that you would have in your normal app, which is really nice because then I can work on a production level code. And also you can bring playgrounds to your own project. So let's say you have a very big application like a Facebook application. It takes a lot of time to compile the Facebook app. So if you want to do rapid prototyping, it wouldn't be possible if you have to recompile the project. So with playgrounds, what you can do is you just add a pod with the playground to the application, and then at any point you can just show the playground from within the app. And it doesn't matter which screen you were on. And there are also some convenience methods for you. So there's a method called setup, which doesn't get re-executed. That means that if you have very expensive operation like a database query or a network request that you have to fulfill before you start iterating, you can execute it only once and then store that data. That allows you to prepare in advance for your rapid prototyping session. And then you can just iterate very quickly. And because it's a full simulator, you have full interactivity. So if you want to work on an interaction like zooming, panning, UI buttons, UI gesture recognizers, well, you can just do that. And then you bring your code to your application and it will work immediately. There is no, the only thing you would remove is DSLs because they just allow you to tweak values. But there is no other code changes that you would ever have to do. And it gets even cooler than that. One of the cool features that Xcode 6 introduced was the previews. So being able to preview your view. So for example, if I'm working on an interface builder, I would like to see the results. And as you can see here, you have the editor, the preview, and the playground. So the preview in the editor is faster because they do it before they save the file. So I have to save the file to see the result in the playground. That's why it's a bit slower. But even that works better with my playgrounds than it works with Xcode, which you will see in a second. Because it's not the full simulator. It's not the full environment that we work with. So if I set something like the corner radius, as you can see, you don't get the preview. So it's skewed result from what you would see on the device when you run it. In the playground, you can see it immediately. And I think it's a huge advantage of being able, especially with custom classes and everything else. It's very helpful. And one of the things I really, really like is being able to give my teammates, my designers, ability to contribute to the project. So with Swift Playgrounds, to be able to run it and tweak it, you have to have the Xcode, right? And you have to know how to write code. One of the advantages of having all the sliders, it's very obvious. You just drag the slider and you see the result, right? So what I want to do is I want to be able to deploy the playground or the prototype to the device, and I can send it to the team. And you can do that with the playground. So here's one of the playgrounds I was working for Mashable at. So we were experimenting with different user experience. And I just wanted to get all of our people on our product team to get their opinion on the values that should be used for the UI. So here I am just able to drag few items and see the results. And at the end, there is this button, I don't know if you see it, it's called Looks Good, which actually opens a mail messenger with all the values filled in, so they can send me the values they liked. And this didn't require anything. I just built the playground. Instead, I selected the device. So I don't get code injection here, but because of the way I built the architecture around it, I was able to get all the sliders and everything else running on the device. So the designers or the product managers could contribute. And I would like to show you a short demo how it works. I think it would be pretty cool. So let me just change. I think I have to change the mirroring. Okay. So here I actually ran it before the presentation, and I can just change the code now, right? So I just commented out a line.runs function, and we are starting with a blank slide. So for example, if I wanted to show you the DSLs, so I can just load my avatar and show it. So on the left side of the screen, you get the history or the timeline. I call it the timeline view. And KZP show is a method that allows me to show multiple types. So maybe I'll increase the font size. 1 second. Oh, that should be visible. So here, for example, the KZP show is a method that allows you to pass any variables. So I can show an image, or I can just go and show a string. And as you can see, the moment I save the file, it's reloaded. There is no delay there. And as you are presenting stuff, you can see what created this log. So for example, here is a UI image. But if I created, let's say, I'll just copy some code from other sample. So I have my avatar, I just comment it out. And then I create a label with the hello world message or hello MCE. So as you can see, I can even change the assets and it's reloading. And you can see that this was UI label, which inherits from UI view, and you can see the size of it. And it's still the same method, so it doesn't matter what type you use. You just write KZP show, and it just shows you the object. I don't really want it on the preview. But then I have a view. I create a view, and I can see how it looks here. So it's UI view, but now I would like to be able to actually add it to the worksheet. So I'll just do add subview, view, And that view is here then, but it's not centered, so view center equals self worksheet center. I save it. That's pretty cool. I would like to make it bigger though. I mean, it's pretty cool, but if we could rotate it, or I'll just make it rotate first. So here I have some value, so I can change the angle of the image, but let's rotate the view itself. So I don't need it on the timeline. And what I want to do is adjust value, rotation, and go from 0 to 360. And then I want to do view transform. So I have to wrap it either in the change value, so when change, and I can do rotation, and then I can do float, rotation. Make rotation, and then I specify the angle, multiply by MP by 180. And 1 second. So I have the rotation here, and I can just start modifying it, which is pretty useful, right? And then I can go even further. So if I wanted it to auto rotate, I will just change the adjust value to animate value, and then let's make it auto reverse because otherwise it just looks weird. And I can now create a view that automatically rotates. And it would be nice if the view was bigger, so I could just scale it up. But we can go further. So for example, so this is still passive, and you could still do it with Swift playgrounds, but you couldn't do this. So let's add a punch recognizer, which is, as you can see, I'm writing regular Objective-C code. And there is nothing magical about it. The only thing that I'm using is the DSL. So I'll create this, and then I'll just add it to the worksheet. And because I'm using real ID, something that actually has refactoring, I can just do this. I didn't have the source kit crash yet. But and if you want to store views, so for example, I don't want to create the property for the view, I can just use persistent. What was the name? Never remember. Yeah, transient objects. I can just use a string as an identifier. I could use ivars, but there is a bit different behavior in how it's stored between reloads. Persistent views are cleared with each code recompilation. So here I can just copy the code from the other method. So I'll just grab the object and I set it centered to the location of the punch gesture recognizer. If I do this, I can start interacting. And this is something that Swift Playgrounds doesn't allow you to do already. And there's so much more you can do with this. So for example, I have some other code here. I can remove all of this code. What's really cool about it, I don't really care. So I can just remove the code. And everyone loves 3D graphics, which is the demo I showed before. So I'll just uncomment method that allows me to show you the scene kit. And as you can see, this is 30 iterations here. Oh, how much you can see it. 30 iterations without code reload. And because this works, it doesn't matter what ID I use. I can even go further, and I can go to the source tree. And I can change the branch I'm on, rescard the local changes, and it reloads the code. So you can jump between branches and features without restarting the project, and just reloads everything, which I think is pretty powerful. And yeah, I mean, here's the example I showed you before, so I can just do some actions, and I can show the bounds of the view, so in case I want to debug it. But then I can go I can go to the code itself. I can change the values. What's really cool about it is also when you are changing from the animation to the manually adjusted value. I'll show you on the other sample. When I'm changing that, it actually remembers the last state. So as I am working on the timeline and I have the scale here, for example, let's find it. So here I have the scale. So I'll change it to be automatically animated. And then if I go back, it remembers that the scale was 133. So even though I'm changing the code and I'm reloading, it still remembers the old values. So as you are tweaking stuff, you don't get to the point when you actually have to change everything back to the state you did it last time. So it's pretty powerful. I think that kind of covers it for the demo. I can zoom in, or not on this one, actually. And it also like visualizes, it's great for learning APIs. So here I'm using the Bezier path. So I'm displaying the Bezier path, and I never remember how the line dash pattern works. Something that kind of should probably learn by now. So I can just change the code. I mean, I can just see what happens. And I can connect it to a variable again, so I can expose it as like the line dash pattern as few sliders, and it would work just fine, which is really useful. So as you can see, you can preview it, you can see the results. And you can make it automatically animate. So here, for example, I'm using multiple sliders, so rotation, scale. So I have the when change or when set DSL, but I also have animate. And anything you put in the animate block, it will refresh with the screen refresh rate with display link, and it will grab the current values. So as you're adjusting multiple values, you can just wrap everything into this simple animate block, and works pretty well. So I mean, from presentation side, I think demo, that should be pretty useful. Let me just go back to the normal. And everything is free, open source, and it's available on GitHub. You can go to my username, Krzysztof Zabłocki, and /KZ Playgrounds. I think I'm ready to take some questions.
Questions? Right here.
Apart from Dicey, do you need any plugin to the app code for this to work? I mean, the auto reload after save.
Okay, so my playground works quite simply. You just add a pod called KZ Playground, and if you have installed the Dicey Clang proxy, it will just work. You don't need any plugins. You just have to save the file when you change it. Just Command S. And it will work.
So when do you actually need to recompile? So when you add a file, where you add assets, or?
Well, as you can see, I was changing the interface builder, and I didn't need to recompile. I was changing the localization strings. I didn't need to recompile. There are cases when I will need to recompile. If I'm adding new files, then I need to recompile, mostly because I don't have the parameters to compile that file on the flight. Because let's say you are adding a new library or a new pod. That's problematic because I need to know what are the exact params that it was built with. Because if you add something like a pop, then it will have different params than a regular application, because it uses C++ and other stuff. And if you are creating a lot of classes, then sometimes you will have to recompile. Or when you crash, you write code that crashes. Yeah?
When you decide the numbers and the animations that you are tweaking, do you leave the code in order to go back there in the future and be able to change it, or do you clean everything for production?
I'm not sure if I understand. So the way I usually work is if I'm working on an interaction or user like a UI views or something like that, I would start with the playground. I would bring it to existing project, or I start from scratch depending on what I'm working on. All the values or the DSLs, if I'm in the playground itself, it really doesn't matter, because you can have it in your project, but the playground won't automatically roll. Like, you have to do something to load the playground, right? There is a convenience that I give you so you can actually show it from any point of your application, but it's a separate class. It doesn't affect your normal code. And what's really cool about it, I did everything in a single file, but this actually works on all the files because it's a daemon. So you can have the playground when you create your custom classes, but you actually write the production code in your classes. Okay. And it will reload it. So I would have in the playground, I would have some sliders to adjust the properties of my views, but the views itself are just pure production ready code. There's nothing related to playground at all. It doesn't have to be. That answers?
Yeah, thank you.
Cool. And other questions? We still have 6 minutes.
Have you ever tried to load like a more complex application into the playground? I mean, I understand that there probably would be a variable state would be reset, but
so the thing about playgrounds, like, it doesn't matter the size of the application. I mean, the bigger the application you're working on, the bigger the benefit you have from using it. So Foldify is quite big up, like, it's 15,000 lines of code because I don't like to write a lot of code, but it's all the external libraries still that I contribute to. But size of the application is quite big. Like, I mean, 30 seconds to compile, that's pretty significant. And it's using like it's using RAM disks and everything. That long period of time is even with all the optimizations and everything else. So the thing is, you don't load application to the playgrounds. It's the other way around. So the playground footprint is very small. So what you have is you have your huge application, like Facebook application, for example, and you just bring this small pod that has, I mean, the playground itself has like 4 classes. You just bring that to your application, and then you just execute it. And the thing is, you just create instances of your classes that you want to iterate over.
Yeah, I mean, you can just create the root view controller of your application, the same thing that's got executed in the application did finish launching, and well, it may look strange, but magically the whole app should appear in your workflow sheet. So it's
okay. So I wouldn't do that. What I would like, that would be like, it's not meant to like replace the whole workflow. It's more like, so let's say you're working on your big application and now you're asked to work.
I'm asking about the idea of replacing the whole workflow. I understand that you can try some toy views and experiment, but what about changing the complete workflow of developing the app?
Okay, so the thing about this is I wouldn't create a root controller and navigate there, because then I would have to simulate stuff. And I'm trying to avoid, because like I wouldn't have the screen, like the navigation controller work the way I would like to, because it's full screen and everything. You could try using that. I kind of feel it would break one of the points, which is I create the production ready code that when I run it, it will behave exactly the same way. So it kind of feels like I would have to do some hacks there to make some of this work. But because of the way it's structured, so for example, you wouldn't change the whole navigation, but if you're working on a specific feature, which is like a create workflow for like Facebook creating the post and everything, you could start from your root controller, and then you could go from there, right? Or you could start from the view that actually creates it, because you have the, I give you also the view controller, so you can do containment, so you could still get that behavior. And you can, what's really nice about it, you just iterate on your normal classes and just create them from the playground. So it's like this bootstrap that you use, but the classes are just regular classes, like no special handling needed.
That's cool. Thank you.
Is it limited only to UI kit stuff, or could you?
Oh no, you can bring anything. I talked with a guy that did audio kit, and he's using that now for all his demo for the code. I actually, like, I went to Commander, I announced this on Commander, and Facebook was doing demo there, so I took their room, and I did demo when I actually bring pop to the playground, and I recreated what they did with Quartz Composer in a couple of minutes with like actual live coding. So you can bring any pod you want, any code you want, anything that compiles on iOS simulator, it will work there, including display kit. Last question? Okay. Thank you, and follow me on Twitter.